Okay, good day everyone. Today we're gonna discuss wind turbine and hydrogen. First is wind turbine. With my group mates, Artates, David M, me, Dela, Cruz, A, Martinez, Khyla S, Mejia, Raqueliza C, and Verdadero, Hari. First is the renewable energy wind turbine. Kung paano siya nagka-conduct ng electricity. Dito, makikita natin marami wind turbine na tinatawag na wind farm. At ganito ang itsura ng wind turbine. Meron siyang rotors na nagko-consist of 3 blades na nakakonect sa hub and sa nozzle. Dito sa laman ng nozzle, which is connected to the blades, na kapag umikot yung blade, iikot din yung shaft, tapos iikot yung gearbox, iikot pa yung isa pang shaft and yung generator. Tapos sa likod, makikita natin yung triangle na to na tinatawag nating wind vane to detect kung saan papunta yung hangin para umikot yung mga blades. Tapos yung tatlong bilog-bilog naman na umiikot na to, tinatawag naman na anemometer to measure the strength of the wind, kung gaano takas. Tapos ayan, pag malapitan, makikita natin. Tapos dito naman yung malayuan na itsura ng wind turbine. Tapos dito naman, wind turbine, ayan, nasabi na kanina, yung type of renewable energy to produce electricity. Tapos, ito lang yung basic idea na diniscuss kanina kung paano nagwo-work ang isang wind turbine. Also dito, sabi, a large number of wind turbine usually called wind farm. Pag maraming wind turbine, wind farm na ang tawag noon para makapag-produce pa ng mas maraming electricity. Ito yung wind turbine. Dito makikita natin yung mga parts ng wind turbine na nakita na rin natin kanina. Yung sinabi ko na kanina na low speed shaft, gearbox, generator, tapos yung high speed shaft, and yung controller. Pero mayroon tayong hindi nabanggit kanina katulad nitong geodrives, yung geosystem, which is geodrive and geomotors. Na basically, madidiscuss pa mamaya. Dito na tayo sa parts and function. Para mas lalo pa nating maliwanagan kung para saan ang mga ito. Kung paano siya nagpa-function. Una ay yung blade. The blade is the part that rotates due to the forces it catches from the wind. Alam naman natin na yung blade, siya yung nagro-rotate. It is connected, nabanggit na rin katulad yung kanina yan, na merong low speed shaft siya sa nakonect sa hub, sa gearbox, tapos generator. Once the blade rotated, causes the rotation of generator, thereby generating electricity. Yan. Dapat kapag bubuo ng wind turbine, dapat lagi may generator. Kasi yun yung nagpo-produce ng electricity. Most wind turbine consists of 3 blades for maximum efficiency. Tapos makikita natin dito, meron siyang brake. Pero mamaya pa naman madidiscuss kung para saan yung brake din. Kasi nasa bait pa lang tayo. In creating a blade in wind turbine, hindi basta-basta ginagawa yan. Dapat alam natin kung paano iikot, kung paano tatama yung hangin sa kanya. At yun, kung gaano kalaki. Tapos, mahalaga daw sa blades ay large and tall. Mas malaki yung mapoproduce na electricity. It is shaped to generate the maximum power from the wind at the minimum cost. Yung wind turbine, dahil nga need ng mas malaki, syempre magagastos ka ng malaki din dyan. Kaya, yun. Nagdi-design sila ng wind turbine na mas mura pero generate pa rin ng maganda o makakapag-perform pa rin ng maayos sa atin, which are more compact, quieter, and generates more power from less wind. Kung tatanungin kung ano yung average na laki ng isang wind turbine o yung blade mismo, dapat daw ay 50 meters. At yung pinakamalaki is yung 170 meter, currently the longest from Siemens Gamesa. Hindi napakalaki nun, 50 meters. Kung ko-convert sa feet, ilan yun? Ito yung picture ng pinakamalaki o yung longest blades, which is Siemens Gamesa. Yan. Haba niya. Mula dito sa dulo hanggang dito. Tapos tatlo pa yan. Ko-connect pa. Gaano kalaki yung wind turbine. Okay, next. Dito naman tayo sa blade design pa rin, which the blade consists of airfoils. Ito na yung airfoils. Yan. Ano nga ba yung airfoils? Is the cross-sectional shape of the blades that determines its aerodynamics. They are key to blade design. This airfoil design allows the blade tips of a wind turbine to move faster than the wind is moving, thus generating more power and high efficiency. Yan. Yung airfoils, nakadesign siya as a cross-sectional air shape. Para pag tumama yung hangin, maganda yung magiging ikot. Dahil pag ganyang shape, mas mabilis yung ikot ng blade. Tapos yung aerodynamics, alam natin yung aerodynamics. It is when the air collides to certain object, magkakaroon ng behavior sa ikot niya. Tapos, yun. Next is nga pala, dito pala muna. Pag hindi ka maalam sa physics, hindi mo alam kung ano yung nagiging malaki yung ikot. Kasi dito, nakadesign siya para maging faster siya sa wind, yung ikot ng blade. Next part sa design is blade aerodynamics. Wind turbines blade works by generating two aerodynamic forces. Yan. Which is lift and drag. This is due to wind and their airfoils. Pag yung hangin nag-collide na sa blade, makakapag-produce siya. Meron siyang dalawang force na maghaharang, which is lift and drag. Yung lift force na muna is perpendicular to the airflow and is in line with blade rotation. Drag force is in line with apparent wind direction, which is in the opposition of the blade motion. Drag increases in proportion to the frontal area of an object facing the wind. Yung lift force mismo, siya yung force kung bakit yung blade ay nagro-rotate. Samantalang yung drag force naman, siya naman yung apparent wind direction o siya yung kumokontra sa lift force. Kaya dito, mapapatanong ka kung ano nga ba ang mas malaki o yung mas magandang tamain. Yung leaf force o yung drag force. Ano nga ba? Yan. Ito yung figure na nagre-represent ng leaf force and drag force. Meron siyang leaf, meron siyang drag, tapos yung hangin kung saan tatama. At ito yung naman yung airfoil. Airfoils. Yan. Dito, sa mga picture na to, makikita natin yung dalawang curved side, which is most curved side and less curved side. Ano ba dapat ang mas malaki? Pag sa leaf force, meron siyang less curved side. Sa drag force, merong most curved side. Kasi pag mas less curved side, mas malaki yung pressure, ayan, which is magdilip. Pero kapag most curved side naman, low pressure lang siya. Kaya dito makakapagdulot ka ng, ang magiging takbo nito is high to low pressure. Kasi yung hangin, pilit niyang aabutin yung less pressure na yan. So, here's now the question. Based on the figure illustrating the optimum angle of attack, ano muna ba yung optimum angle of attack? Yung optimum angle of attack, dito magbabase kung saan tatama yung hangin. Dito, yung hangin na yun, siya yung makakapag-tilt ng blade. Kung paano siya mag-tilt. Maraming design na, iba't ibang uri ng design ng airfoils. Kaya dapat alam mo kung alin yung most curved side and less curved side for optimum angle of attack. Which part of the blade is the leading edge and trailing edge, front and alam naman natin na kung alin dapat yung leading edge. Edi yung less curved side. Tapos yung trailing edge yung most curved side. Kasi i-reach niyang pilit yun. Tutulak siya pataas yung hangin. So, blade rotation. Question, what will be the rotation of the blade? Is it pushed to the side that has no more curve or pushed to the side that has less curve? Ikaw, pag tinanong, kunyari may tanong sa'yo na someone, paano nga ba umiikot yung blade? Hindi, siyempre, pag tumama yung hangin, napakasimple ng sagot mo. Hindi, para mas magandang sagutin, mas magandang magiging sagot natin sa kanya. Or to look like an engineering, gano'n. Siyempre, ang sasagot mo is kung paano nag-work yung blade. Alam naman natin yung direction ng hangin kung saan dapat pupunta. Siyempre, leaf. Ayun. Una sa less curve, pupunta sa most curve. Blade wind orientation. The photo shows the front side and back side as well as the leading edge and trailing edge of the blade. Dito sa photo na to, tulad ng mga na-discuss na natin kanina, kita-kita na natin yung wind turbine. Kung saan dapat nakatapat yung leading edge, yung trailing edge. Ayan. Para mag-rotate ng faster yung blade.
Let us continue the discussion with additional information about the blade design of a wind turbine. Parts and design, blade design. in addition to its curved design, twisted and tapered blades further enhance its aerodynamics, with the combined effect of twisting and tapering the blade along its length improves the angle of attack, increasing speed, efficiency, and lift while reducing the drag force. So as we can notice, blades that are used in a wind turbine are not as perfect as the one that we used for cutting. So blades in a wind turbine are specially designed to provide greater capacity of energy by spinning or rotating faster than it could be. So here is now the question. Based on the previous slide, what number of blades is the best design in consideration of all the factors in construction and operation of a wind turbine? If we insist that the blade is intended to spin faster while functioning well and properly, how many blades is the best for its design? So we already know that the rear of the blade is curved more than the front. This varied shape causes a pressure differential when the air moves across the blade, which is what causes the blades to move. It only means that if the air hits the drag point of the blade, which is the concave part, it will create a pressure difference along the blade, whereas the higher pressure will look for a way to go to the lower pressure, causing the wind turbine to rotate. So because of the obstruction of the blade, air moves at a faster velocity behind the blade than in front of it. This is what sets the rotation of the blades in motion. So as I said, the difference in pressure causes the rotation. So as the air travels from the high pressure to low pressure, the blades will rotate accordingly. Engineers must consider speed and drag in designing the blades to ensure the highest level of efficiency. For example, if too much drag is created by the obstruction of the blades, the power yield will be a lot lower. If not enough drag is created, the blades could move too quickly, causing them to break the sound barrier. So, if the blades are needed to be perfectly designed, do consider the speed of rotation. It can't have too much drag force or too much lift force because it can alter the operation. Engineers often create a design to improve its capacity to move faster. So the rule of thumb are the fewer blades the better, since there will be less drag and an increase in efficiency. So it only means the fewer the blades the better, because the number of the blades increases the torque and reduces the optimum rotation speed. So having fewer blades reduces the drag. As the number of blades increases, the rotation speed decreases. Considering this fact, we can see that the number of blades is inversely proportional to its speed. So consider natin yung one blade. Because of the decreased drag, one blade would be optimum number when it comes to energy yield. But then, there's the problem. So, however, one blade could cause turbine to become unbalanced. And this is not a practical choice for the stability of the turbine. Why? One blade is not ideal because it can cause unstable rotation during operation. As we can see, we need the turbine to spin properly. Therefore, one blade can't be used. So, two blades. Let us consider two blades. So, at first glance, two-bladed turbine seem like the optimal configuration for wind turbine. Perfectly balanced and with one blade less than a three-bladed turbine, they will generate less drag. So, why aren't all turbines made with two blades? Now, two blades look balanced, and in addition, it is the minimum blade if one blade can be used. So, why does engineers didn't use this? Because it has troubles in yawing. So, what is yaw? Yaw is when its head or nozzle turns to face the wing. Due to an effect called gyroscopic precision, when two-blade turbine yaws, it creates a wobble as the blades go from the vertical plane to horizontal Y plane, which places additional stresses on the mounting bearings, wearing them down faster. So except for the fact that it is balanced, turbines also need to adjust or move where the wind is moving. If we use these two blades upon facing and moving to the direction of the wind, the two-blade design can be wobbly and it can cause the parts to wear down faster. So it's not that ideal either. Because if we have more than 3 blades naman, what will happen? Any number of blades greater than 3 could create greater wind resistance, so slowing the generation of electricity and thus becoming less efficient than a 3-bladed turbine. If there are more than blades, it will slow down the rotation as well as its power to generate more electricity. Considering all these factors, what is now the perfect number of blades? So, 3 blades. For these reasons, turbines designed with 3 blades are the ideal compromise between high energy yield and greater stability and durability of the turbine itself. So, aside for being balanced, it is the least number of blades that we can use to maximize its capacity to generate electricity by rotating perfectly and moving alongside the wind. Blade tilting mechanism. Now, according to the wind speed, the relative velocity angle of the wind also changes. So, as we all know, wind is unstable. It came from different directions in different time. Therefore, the blade tilting mechanism is considered. So, what is a blade tilting mechanism? A blade tilting mechanism is the sensor coupled parts of the wind turbine which tilts the blade and guarantees a proper alignment of the blades with the relative velocity so that its position is always at the optimum angle of attack. Now, the nozzle, the housing of the back of the blade which contains the slow speed shaft, gearbox, generator, and other small parts inside it. This part acts like a skin that protects all the parts of the wind turbine to function well and properly upon its operation. The gearbox, the component which converts the slow rotation of the blade into faster speed. This is needed simply because the rotation of the blade generated from the force of the wind is usually not enough for a generator to achieve a great quality voltage output. So most generators need to be turned at 1500 RPM for 50 Hz and 1800 RPM for 60 Hz. In no way it is feasible for the turbine blade to move that fast. So this gearbox is attached so that the wind turbine can actually produce more electricity that it can be. In one rotation of the wind turbine, the gearbox rotates n times of its speed. So a common ratio is about 90:1 with a rate of 16.7 RPM input and rotor to 1500 RPM output for the generator. So imagine how the gearbox moves. If it has 9 rotation in one rotation of a turbine, it literally can generate more electricity. So beside this design, there are alternative designs. We have the direct drive or the gearless. In a direct drive turbine, there is no gearbox. The main shaft spins the generator directly, causing it to spin at the same speed as the turbine blades. Comparing to gear type, the slow rotation and decrease in moving parts of permanent magnet direct drive generator produces fatigue and stresses on the turbine, resulting in reduced noise and vibration, longer lifetime, and lower cost of maintenance. So beside the gear type wind turbine, we can also have turbines that doesn't have the gears. Besides, it can also move as fast as the gears. So aside all this, because it uses a magnet in its operations, it has less noise and vibrations, causing a longer lifetime and lower cost of maintenance for the wind turbine. So hindi lahat ng turbines na makikita natin ay gumagamit ng gears. So we also have gearless ones. That is more applicable kung gusto natin ay lower maintenance.
So, hi guys, I am Raqueliza C. Mejia and I will continue the discussion about wind turbine and andito na nga tayo sa alternative design, direct drive gearless. Nasa gearless na tayo. So, sabi dito, an important fact is that due to wind inconsistency, the gear type turbines often operate of partial loads. The efficiency of the PMDT generator excels even in these conditions because it continues working nearly to nominal values. This design makes suited even in offshore wind application. Sabi dito, suited siya sa mga offshore kasi kahit na hindi siya ganun kahangin, mas maganda pa din yung pag-generate niya na energy and also more efficient siya yung PMDT generator. Nag-excel siya sa mga condition kasi nga continue yung working niya in nominal values. Next, one of the main disadvantage of PMDT is that to make up for its slower rotation and more magnets are added to create the required frequency power. This increases the diameter of the generator, which makes it larger and often heavier than gear-type wind turbine. Another thing is that the additional magnets being used in this type is made up of neodymium, which is expensive. Sabi dito, yung gearless na ginagamitan ng maraming magnet, which is yung ginagamit na magnet natin dito sa gearless ng wind turbine, is yung neodymium na may kamahalan. Kasi nga, yung the more na mas malaki siya and mas mabigat at mas unlike sa mga gear type na wind turbine. Tapos, sabi dito, yung advantage daw dito ng PMDT, mas mabagal daw yung rotation niya kasi nga mas maraming magnet yung nilalagay natin na nagka-create ng frequency and power. Pero yung pag-increase naman ng diameter niya, nagge-generate ng larger and often heavier than gear-type wind turbine. Yun nga sabi ko kanina na, di ba, yung mas malaki siya or mas mabigat nga siya unlike sa mga gear-type na ginagamit natin sa wind turbine. Tapos yun nga, di ba, sabi din kanina na madai kasi tayong magnet na nilalagay dito sa gearless. Tapos yung magnet pa na nilalagay natin doon, yung type ng magnet na nilalagay natin is yung neodymium. Yung neodymium kasi, isa siya sa mga pinaka-expensive na magnet. The cost and weight of the direct drive turbines have prevented it from presenting major competition to the gearbox turbines until recently, but other experts claim that the direct drive technology eventually become the dominant one since the gearbox wind turbine is almost at its maximum efficiency point, while the PMDT generators have more possibilities for improvement. Costly and mabigat siya, unlike sa ibang wind turbine, di ba nga? Pero sinasabi ng mga expert na sa mga susunod na panahon daw, mas maganda yung gamitin yung PMDT kasi nga may maximum efficiency point siya, tas throughout the process. And less maintenance and mahaba nga yung nagiging buhay niya unlike the other wind turbine. Kasi parang mas highly recommended to na mga expert na gamitin yung mga gearless na wind turbine kasi nga mas tumatagal siya unlike sa mga gear type na wind turbine. Tapos, di ba sa yung PMDT generation, yung gearless na to, sa in the near future, mas marami pa siyang mga possibilities for improvement. Dahil nga sa technology natin ngayon, ayun. Tapos, basta, sabi lang dito, yung mga expert daw, parang na pinupush nila na sana ito na lang yung gamitin natin, yung gearless. Kasi nga, mas mahaba yung buhay niya at mas matagal natin siyang magagamit. Tapos, isa pa sa gearless na to, yung less fatigue siya and nakakapag-reduce siya ng energy and nare-reduce niya yung stress. And napoproduce niya yung mga kapag maraming ang napoproduce, reduce stress siya. Tapos kapag maraming gearless ang nagagamit sa wind turbine, less maintenance pa yung gearless na to. Kaya lang, yun nga, mas mahal siya unlike the other wind turbine na gear type kasi nga dahil sa magnet na ginagamit natin. Tapos yun, less maintenance nga lang siya and matagal magagamit. So, parts and functions sa brake. The brake system in a wind turbine is a protected device coupled with sensors which automatically stop the rotation of the blades whenever it detects activities that could harm the system during operation, very high wind speed, vital parts, not working, maintenance in power lines, and etc. Sabi dito, yung brake system daw, ito yung wind turbine na parang siya nagpaprotekta sa device, which is, ito yung brake yung nakakasense ng if may danger na papalapit. Para kapag may danger na papalapit, automatically nag-i-stop yung rotation niya. Kapag nakaka-detect lang ng mga makakasakit na during operation. For example, yung mga matalakas na hangin, tapos yung mabibilis, tapos may mga vital parts na hindi na gumagana or kailangan na ng maintenance sa power lines. Tapos kapag kapag nade-detect ng brake, kapag masyadong mabilis yung hangin na pwedeng makakause ng harm sa wind turbine, kumbaga siya yung pumipigil, yung brake. Next is yaw system. Yaw system is a sensor-equipped mechanism consisting primarily of yaw motor, yaw drives, and others. Its function is to automatically rotate the nozzle on top of the tower so that the sets of plates is facing the wind directly at all times. It detects its proper direction through the electronic information being fed by the wind vane located at the back. This ensures that the wind turbine is producing the maximum amount of electric energy. So, sabi dito sa yaw system, siya yung taga-locate ng hangin kung saan mas magandang tatama yung wind turbine. Tapos na-maximize na yung pag-produce ng electric energy and mas na-align niya yung wind turbine sa wind direction. Sabi dito, halimbawa, ito yung wind turbine, tapos andito yung yaw system. Parang kung saan yung hangin, gumaganon siya, ganon. Parang nade-detect niya automatic na nalilipat ganon kung saan man nagda-direct yung hangin para makapag-produce ng electric energy. Tapos, sabi dito, basta naka-automatically rotate siya kung saan man umaano yung hangin, kung ano yung pinapace niya. Pag ganon. Halimbawa, eto, ayan. Ganon. Kasi halimbawa, ayan. Automatically nililipat ganon. Kapag ng hangin. Nakadetect ng hangin. Yan, gumaganon. Para makapag-produce ng maximum amount of electric energy. Yung tower naman. Tower is a wind velocity increases at higher altitude. This means the taller the tower, the greater electricity it can produce. Majority of wind turbines are supported by conical tubular steel towers with a height of usually 75 to 110 meters or 250 to 370 feet depending on the blade's diameter. The tallest steel for completion in the mid of 2022, which is 280 meters, to be installed at a test center in Western Jutland, Denmark. So, sinasabi lang dito na the more na mataas yung tower, the greater the electricity it can produce. Mas madaming mga electricity mapoproduce niya. And sinasabi dito na yung height of the tower, usually yung height ng tower daw, is nag-exceed lang na 75 to 110 meters. Sa feet naman, in feet, 250 to 370 feet. So, imagine gano'ng kataas yun, di ba? 250 to 370 feet, tapos ng 75 to 110 meters. Siyempre, nakadebate pa rin siya sa blade's diameter. Tapos sabi dito, yung pinakamataas daw na tower noong 2022, which is yung 280 meter. Naka-center siya sa Western Jutland, Denmark. Tower and blade diameter ratio. Noong 2000, meron tayong 173 feet, 2010 to 175 feet, 2020, 410 feet, and 2016, 492 feet, and in the future, 2035, expecting na meron tayo, wala pa. So, ayun. Mapapansin natin dito, the more na umaano yung panahon, parang tawag dito, yung tumatagal yung panahon, tumataas lalo yung tower natin. Kasi ano yung dahilan? Siyempre, mas nag-i-improve yung mga technology natin, ganon. And di ba nga sinasabi na the more na mas mataas yung tower, mas maganda yung generate niya ng electricity. So, ayun. Ideal location. The best place for wind farms are in coastal areas at the top of the rounded hills, open plains, and gaps in mountains, places where the wind is strong and reliable. Some are offshore. To be worthwhile, there should be an average wind speed of around 25 km per hour. So, sabi dito, the best place daw ng pag-place ng wind farm sa mga coastal areas, sa mga taas ng mga rounded hills, at sa mga open plains, sa mga bakante, sa mga maluluwang na place, yung mga open area, ayon, sa mga mountains. Tapos di ba sinabi ko kanina na suited siya yung wind turbine i-place sa mga offshore, lalo na yung gearless type. Kasi hindi siya ganun kalakas yung hangin, tapos mas maganda din yung pag-generate nila ng energy. And sabi dito, yung average ng wind speed ay nag-average lang siya ng 25 km per hour. So, parts and function. Yung advantages is wind is free, wind farms need no fuel, produces no waste or greenhouse gases, the land beneath can usually still be used for farming, a good method of supplying energy to remote areas. Sabi dito, advantage, wind is free. Wind farms, hindi na natin kailangan ng fuel. Which is, diba alam natin today na napakataas ng gasoline ng fuel? Nagpo-produce siya ng no waste or free greenhouse gases. Walang mga pollution, walang mga greenhouse gases na nakaka-affect sa ating mundo. And the land beneath can usually still be used. Diba alam naman natin itsura ng mga wind turbine. Tinatayo lang natin siya. So, yung land na pinagtatayuan natin na yon, pwede pa natin siyang gamitin para sa mga pagtaniman natin, sa mga farming, ganon. And good method of supplying energy to remote areas. Okay siya sa mga lugar na malaging walang kuryente, ganon, para nakakasupply tayo ng energy sa kanya, mas malaking tulong. So, disadvantage, the wind is unpredictable, it changes speed throughout the day and season to season. So, we humans, na ipapredict ba natin yung speed na yung wind? Syempre hindi. Minuto, segundo, nagbabago yan. And season to season, ganon. The suitable areas for wind farms are often near the coastal area where the land is expensive. So, di ba nabanggit natin kanina kung saan ideal yung paglalagay ng mga wind turbines? Doon lang siya sa mga coastal, malalapit sa coastal area or sa mga offshore. Kung saan, mahal yung mga lupa doon, yung mga land, mga expensive. Tapos, can affect television reception on nearby places. Nakaka-affect siya sa television reception sa malalapit na lugar. So, may 7 largest wind farm tayo. 6 may largest wind farm. So, ang pinakamaluwang na one of the largest wind farm is Gansu Wind Farm. Meron siyang capacity na 7,965 megawatts and sa country ng China. Next is Alto Wind Energy Center, 1,548. Matatagpuan siya sa California, USA. Mupandal Wind Farm, 1,500 megawatts, India. Hornsea Project 1, 1,218. Matatagpuan siya sa UK. And Mark by Den Wind Farm, meron siya 1,120 megawatts, matatagpuan sa Sweden. And Heisalmer Wind Park, 1,604 megawatts, matatagpuan naman siya sa India. So, let's talk about sa pinakamalaking wind farm, which is sa China. So, yung Gansu Wind Farm Project or Huaquin bases a group of large wind farms under construction in Western Gansu province in China. In 2008, construction began on a 750 kV AC power line to carry electricity from the wind farm, and construction of the wind farms themselves started in August 2009. In November 2010, officials announced the completion of the project first phase involving the installation of over 3,500 wind turbines with an installed capacity of approximately 5,160 megawatts. And yung nagastos nila dito is inabot ng 120 billion Chinese yuan or $17.5 billion. The project is being built by more than 20 developers. Napakalaki. Diba? Ano pala siya? Inabot siya ng 120 billion sa Chinese yuan. So, imagine magkano yun in peso. Tapos, nag-start siya noong August 2009. Tapos, nung natapos siya, November 2010. So, it's almost, mahigit 1 year lang nilang nagawa yun, di ba? Nakapag-install na agad sila ng 3,500 wind turbines na may capacity ng nag-approximate ng 5,160 megawatts. Next is, second to the large, the 150 megawatts Burgos wind farm is the largest wind power project in Southeast Asia located in Burgos. I know, it's not second to the last. Matatagpuan siya sa Philippines. Oo, hindi siya second to the last. Matatagpuan na wind farm sa Philippines sa pinakamalaki. The 150 megawatts Burgos wind farm is the largest wind power project in Southeast Asia located in Burgos, Ilocos Norte, Philippines. The estimated cost for the construction of the wind farm was $450 million, which was completed in 2015, located within a 600-hectare site. The facility consists of 50 wind turbines, each with a capacity of 3 megawatts, generating electricity to the Luzon grid. Each wind turbine rests on a top tubular steel tower, has a 75 meters hub height and 90 meter rotor diameter. So, sa Southeast Asia naman, may matatagpuan yung largest wind turbine sa Southeast Asia na nakalocated sa Burgos, Ilocos Norte, Philippines. And natapos daw siya way back in 2015, located in 600-hectare site. And yung capacity niya is 300 megawatts nagko-consist ng 50 wind turbines na nagge-generate ng electricity sa Luzon grid. So, grid operation. So, paano nga ba nag-ooperate to? Diba makikita natin yung blade dito? Ayun yung blade. Papasok doon yung sa blade, papasok doon yung hangin. Tapos kapag pumasok doon magge-generate ng wind. Which is papasok siya dito sa may transformer. Ay hindi ba yung wind papasok dito, tatama siya sa blade, tapos sa may hub, tapos speed up gearbox nozzle, tapos generator. Ito yung generator yung nagpapagana doon. Tapos yung generator nakakonect siya sa power converter. Yung power converter, nakaano siya sa may transformer para makapag-generate ng hangin, ng electricity. Tapos parang yung hangin na pumapasok, iikot yan, tapos saka sila makakapag-generate ng mga electricity. Ganun lang naman nagwo-work ang wind turbine sa grid operation. Basta pag may pumasok na hangin, iikot, and mag-generate sila, papasok siya sa generator, tapos ipapasok siya yung blade, papasok yung hangin sa blade, tapos iikot ng kusa yun. Tapos para magtutuloy-tuloy siya sa part na to. Then yung sa transformer, ayun, makakapag-generate sila ng electricity. Doon palang gagana yung electricity kapag umabot na sa baba yung ano. Diba? Parang madedetect nga din nila. Galing, diba?
So, ngayon naman, ang pag-usapan natin is itong another source of renewable energy or electricity, yung hydrogen power plant. A brief description lang ng hydrogen power plant. A hydrogen power plant is a concept design for a new widespread source of electricity. Concept pa lang siya, idea, hindi pa siya talagang nagagamit for the production of electricity. Pero under research pa siya or under development dahil meron pa siyang mga problema na kailangan user like costly, masyadong mahal yung pag-produce ng o yung production cost niya. Yung ginahanapan pa ng paraan para maging sulit yung gastos na gagawin. Essentially, it is a facility which uses hydrogen to produce electrical energy. Yung pinaka-fuel ng plant na to is yung hydrogen. Working principle, large tanks of liquid hydrogen will feed into thousands of hydrogen fuel cells. These fuel cells are solid structures containing an electrolyte fluid and two terminals, much like batteries. So, itong hydrogen power plant, gumagamit siya katulad ng nangyayari sa isang battery. The main part in hydrogen power plant is the hydrogen fuel cells. And the working principle of fuel cells is same on how batteries work. If we want to know the principle on how hydrogen fuel cells are working on the power plant, we need to dissect the parts of battery because the working principle of hydrogen fuel cells and battery is the same. So, para mas maintindihan natin yung sistema o yung concept o ano ba yung nangyayari sa isang hydrogen power plant, ang pag-aralan muna natin is yung battery, kung paano ba siya gumagana dahil magkamuha. So, ito, battery parts and functions. Electrolyte, meron siya electrolyte, anode, at yung cathode. So, electrolyte, it is a chemical compound that conducts electricity by changing info ions when melted or dissolved into a solution. It can be liquid or paste-like substance. At ang example niyan is ito, ammonium chloride, zinc chloride, potassium hydroxide, lithium tin, phosphorus sulfide, and sulfuric acid. Ito namang anode, it is the negative or reducing electrode na nagre-release ng electrons to the external circuit at ina-oxidize niya during the electrochemical reaction. Ang examples ng anode ay zinc, metallic lithium, at lead. And ito, yung last one is yung cathode. Ito naman yung positive or oxidizing electrode na nag-acquire ng electrons from the external circuit and it is reduced during the electrochemical reaction. Examples ng cathode natin is manganese dioxide, carbon, lead dioxide, and copper. So, meron tayo ditong schematic diagram ng battery para maintindihan natin paano ba siya gumagana. Merong two sides, itong anode and then cathode. So, sa gitna niyan, hindi lang pinakita sa diagram, merong barrier. Paano ba siya gumagana? Sa anode side, yung anode at yung electrolyte solutions, nakadesign siya para magkaroon ng chemical reaction na magpo-produce ng excess electrons, sobrang electrons. So, itong side na to, ito yung negative side. Dito naman sa kabila, yung cathode natin. Yung cathode at yung electrolyte solution, nakadesign naman yan para magkaroon ng chemical reaction and yung reaction na yun is magpo-produce ng electron acceptor. So, pagka dito sa anode side natin is meron ng excess electrons, ang tendency niyan is talagang mag-move yung electrons, diba, same charges literally. And hahanap siya ng positive particles para maging balance. So, dahil nga merong barrier dito sa gitna, pwede tayong mag-connect ng wire or circuit sa kanilang mga terminals and yung electrons na sobra is dun tutuloy. Yun yung magiging kuryente papunta rito sa cathode. Dito sila mag-init and mapoproduce na yung kuryente na nais natin sa battery hanggang sa ma-discharge na yung battery natin. So, ito, summary. On the diagram, the anode and the cathode are submerged on electrolyte solution. On the middle of the two is a semi-permeable barrier. Yung harang sinasabi ko ano. And then when the anode submerge on electrolyte, they produce excess of electrons because of chemical reaction. If there are excess of electrons, they repel each other and try to go on a place with fewer electrons. When the cathode submerge on electrolyte produce electrons, electron acceptor because of the chemical reaction. The line that connected on the two, the anode and the cathode, this is the line where the excess electron go to the electron acceptor or the cathode. And this is the working principle of batteries. So ito, parts ng batteries ulit, meron tayong metal pack, carbon rod, zinc case, manganese, ammonium chloride, and then metal bottom. maraming types ng batteries, pero dito, for example, zinc carbon batteries, wherein ang anode niya is Mg. At yung cathode is made up of manganese dioxide, and nag-a-add tayo ng carbon para i-increase yung conductivity niya. Ang electrolyte solution na ginamit is ammonium chloride. So, dito naman tayo sa hydrogen fuel cell. Diba sabi natin ganun, yung batteries and yung hydrogen fuel cells almost the same lang ng working principle. So, dito makikita natin meron din siyang anode side and meron din siyang cathode side. Tapos, meron silang membrane dito sa gitna, which is called the proton exchange member. At meron siyang catalyst na platinum. And para sa may catalyst na yan, pag-uusapan din natin namin. So, paano siya gumagana? Dito sa anode side, nagsusupply tayo ng hydrogen. Di ba nga, ang hydrogen yung pinaka-main fuel natin dito sa power plant. So, pag nag-supply tayo ng hydrogen dyan, yung hydrogen sa tulong ng catalyst natin na platinum, mabe-breakdown yung particles niyan into smaller particles na dalawa, positive and negatively charged particles. So, yung negatively charged ng electrons, dito siya mapupunta, dadaan siya sa ating wire or sa circuit at lilipat siya dito sa kabilang side, which is the cathode. Ngayon, ang trabaho nitong barrier, ang hinahayaan lang niya na dumaan sa kanya is yung positively charged particles. Kaya yung electrons, iikot siya dito sa circuit sa wire na kakabit natin. And then, pagdating nilang dalawa dito sa cathodic side, mag-meet ulit sila dyan, mag-reunite. And sa tulong naman ng platinum ulit na catalyst natin, yung oxygen is masasama dun sa dalawang particles, magkakaroon ng reaction. And magpaproduce yan ng ating byproduct na air and water vapor sa heat. So, ayan, yung cycle natin is paulit-ulit lang. Kailangan talaga ng hydrogen fuel and oxygen from the air. Yun lang yung kinaibahan niya sa battery. Sa battery kasi hindi mo kailangan ng supply ng hydrogen and oxygen. Pero dito sa hydrogen fuel cell, kailangan para mag-work yung power plant. So again, summary naman ng hydrogen fuel cell. The anode side is the hydrogen and on the cathode side is the oxygen. This is the working principle of it. When the molecules of a hydrogen reacts on the catalyst made up of platinum, these hydrogen molecules, the molecules split into two smaller particles, the proton and the electron. These two particles are heading towards the cathode. And the twist is the electron will travel on connecting wire and the proton can pass on the proton exchange membrane. Well, simply because the electron can enter the membrane and take another path towards the cathode. On the catalyst and the cathode, the two particles are united and combined with oxygen tanks with the aid of catalyst. Ito lang ng catalyst. The byproduct of this is water or water vapor, and the output is direct current. So, gumagamit pa ng inverter para maging alternating current.
How does a fuel cell vehicle works? So, as we discussed, a hydrogen fuel cell works much like a battery, wherein there is what we call two sides, which is the anode side and the cathode side. In anode side, this is where a magic happens, wherein if you put a hydrogen fuel to the anode side which have a solution, it will split the hydrogen fuel into two, which is the charges of proton and electron. So in hydrogen fuel, there is a barrier between the two sides, the anode and the cathode sides, which is what we call a proton exchange membrane. So that proton exchange membrane ay pinapalampas na lang dito yung tinatawag nating protons or positively charged. So, maiiwan sa kabila, sa anode side, yung negatively charged. So, since a positive and negative charge attracts each other, hahanap ng paraan yung electron para makapunta dun sa kabila, which is yung what we call the cathode side. So, in anode and cathode, kapag nilagyan natin ng wire or copper coil or wire between the anode and the cathode, dito dadaan yung electrons. Since ang definition ng electricity is the flow of electrons, kapag dumaan ng electrons dito sa may wire, ito na yung tinatawag nating electricity. At itong electricity na to, doon sa may wire na yon, kapag kinabitan natin to ng mga ilaw, or ito na yung nagpapagana sa mga ilaw or sa mga sasakyan, sa mga motors, kaya nagkakaroon ng electricity. At ang nangyayari naman sa may cathode side, meron din naman tayo dito sa, since it is a fuel cell vehicle, how does a fuel cell vehicle works? Since nag-meet na yung positive and negatively charged or hydrogen sa cathode side, meron naman tayong isa pang input na tinatawag nating oxygen. At meron din namang solution which na kapag nag-interact yung oxygen at yung hydrogen dun sa may cathode, pag nagsama sila, ito yung tinatawag nating ito yung magiging byproduct ng fuel cell, which is the air and water vapor. Ito na yung na-create, or kapag nagsama yon, magiging tubig, H2O. And that is how a fuel cell vehicle works. And also, in hydrogen fuel cell working principle, since nabanggit ko na kanina na it work much like a battery, they do not run down or need recharging kapag hydrogen fuel cell. They can produce heat as long as fuel is supplied. And also, hydrogen atoms enter at the anode. Ito na yung atoms na kapag pumasok sa may anode side, nakapag-interact siya dun sa may solution, pinaghihiwalay na yung positive and negatively charged. At yung positive charge ay makakadaan sa proton exchange membrane, at yung negatively charged ay hahanap ng paraan para lumipat doon sa may cathode side. Since yun, doon nilalagyan ng wires. At also, lagi nating tatandaan na kapag hydrogen power plant, ang pinaka output na kuryente na nanggagaling dito is a DC or direct current. So, kung magsusupply ka or kapag power plant ka, pag magsusupply ka ng kuryente gamit yung hydrogen power plant, kailangan mo pa ng inverter para ma-convert mo yung direct current into AC current, which is yung AC current naman yung magiging magsusupply naman dun sa mga gagamit ng mga kuryente sa mga pangmalayuan, mga ganun. And also, we need to step up transformer because we have to avoid further losses of electricity. So, since na-convert mo yung DC supply ng hydrogen mo into AC at magsusupply ka sa mga pangmalayuang lugar, kailangan natin ng transformer para to avoid further losses due to very long transition line in the power in every substation. So, fuel cells have several benefits over conventional combustion-based technologies currently used in many power plants and passenger vehicles. So, hydrogen daw is a very efficient fuel source, capable of producing more energy per pound of fuel than gasoline. So, ganito lang naman pagkomparahin yung gasoline type at yung hydrogen type na vehicles. Kapag ang hydrogen type or hydrogen fuel vehicle, ikinumpara mo sa may gasoline fuel vehicle, mas malayo yung kayang i-travel ng hydrogen fuel cell because mas tipid itong gamitin kaysa doon sa may gasoline. At also, may isa pang benefit ito. Ang hydrogen fuel ay mas safe kaysa doon sa gasoline kasi ang output ng hydrogen fuel ay fuel cell sa vehicle. Ang output nito is water. So, hindi ito water or air, water vapor, ganun. Hindi ito harmful sa ating environment. Pero may isang factor bakit hindi masyadong laganap itong hydrogen fuel cell. So, ito yung isa sa mga dahilan why it hasn't gone mainstream. So, hydrogen production through methane. About 95% of the hydrogen used today is produced by a process called steam reforming, separating hydrogen's atoms from carbon atoms in methane. This process is expensive. So, expensive. Ito yung isa sa mga cost kung bakit hindi laganap ang mga hydrogen power plant. Masyadong mahal ang kagamitan nito, which is yung platinum, yung largest component material ng hydrogen fuel cell. Kaya masyadong mahal kaya hindi pero hinahanapan na ng mga scientists kung paano ito masusolusyonan. So in steam reforming, this process is expensive and it releases greenhouse gases which contributes to global warming, thereby cancelling out any benefits to the environment. Ito naman yung isa, yung hydrogen production through water. This method is called electrolysis, which separates hydrogen from water. The downside is that it is expensive for hydrogen to reach its full potential as an energy source. Masyado daw mahal. So scientists need to figure out way to produce it not that expensive. Ito yung main dahilan, yung cost. So, in hydrogen storage, scientists are still struggling with the challenge of how to store hydrogen. So, nahihirapan pa daw because it has a low energy density. Hydrogen needs to be kept under strong compression to be a viable fuel source. And also, isa din sa mga dahilan is yung hydrogen leak. So, sa mga ganito, hindi maiwasan talaga yung mga leakage. So, ito yung na-report nung June 2003 ng Science Magazine that hydrogen leakage from widespread use of hydrogen fuel would gobble up ozone faster than CFCs do. So, that's it why it hasn't gone mainstream. So, ang latest development naman, yung Long Range Energy Generation Project. Ito yung first of its kind ng power plant in the United States. The Long Range Energy Generation Project na nakapag-create daw ito yung hydrogen power plant nila ay nakapag-create ng 485 megavolts, which being equipped to run on a mix of natural gas and carbon-free hydrogen. And also, matatagpuan nito on the United States. And is nearing completion at the site of a former aluminum smelter on the banks of the Ohio River. And also, ang pinaka-latest na development is yung power plant na ginawa pinangalanan ng Siemens Energy. Construction begins on world's largest green hydrogen power plant, part of unique base solar project. So itinayo ito doon sa French Guiana, which will provide 10 megawatts of power during the day and 3 megawatts of power during at night. So, a unique baseload renewables project that combines the world's largest hydrogen power plant with a 16 megavolts machine for electrolysis of water and a 3 megawatts and fuel cell, 55 megawatts of solar panels and 20 megawatts or 38 megawatts per hour of batteries has begun construction in French Guiana. So that is all for the hydrogen fuel cell or hydrogen power plant, hydrogen renewables energy sources.